You see how I set up my talk before I start the talk, because I'll be using some of the features that you see in the talk in the setup itself. So I'm going to run a server program. So I'm just going to run a server program. It's going to open up a terminal window. And I'm going to set up some terminals that I'm going to use in my talk. Okay. Hopefully, I made my talk fonts bigger, so you should be able to see it there. So what I'm setting up is 3 terminals that I'm going to embed in my slides. And I'm going to pre-fill the commands so that I don't have to type them in again. So we'll get to that in a moment. So I'm going to a directory which has some notebooks. And I'm going to open up a notebook that has my talk. So let me go into presentation mode. Okay, so I'm getting started with my talk. So I'm going to talk about setting up a browser-based virtual computer lab for classroom instruction. And I'm actually delivering this using that same software. And if you want to look at this talk, you can actually look it up on GitHub. It's at this short URL, goo.gl/O-J-O-k-J-R. So this is a picture of a computer lab, and it's a typical computer lab, but I think in 5-10 years this might be a thing of the past. But one of the things you see in a computer lab is rows of terminals and people seated in a way that's usually different from a regular classroom. There's more space between the rows and people can move around and talk to each other. You can see 2 people talking to each other. There's a person raising his hand to attract attention of the instructor. So these are the typical things you might see in a computer lab as it exists today. So the question I'm asking is, what are the advantages of physical computer labs? You have uniform hardware and software. You can monitor students' progress by looking at the terminals. You can raise a hand to request assistance. You can see each other's screens to collaborate. And you can also share files by putting in a common file system. Some of the disadvantages: the hardware costs money, and students have much more powerful computers now. You need to create a user account, install software, and often I find that if I need to fix something in my university's computer lab, I need root access, and my sysadmins don't give me that because they want security ensured. And you need to be there to use the lab, and students would like to use the lab when they're not around. So my background about myself, I'm actually a climate modeler. I use supercomputers to model climate change, and I also teach courses in meteorology. And I've been teaching an introductory programming course for the last 5 years for meteorology majors. I've used IDL for 3 years, and for the last 2 years we switched to Python, and we've been using IPython notebooks for the last 2 years, more so this year than last year. And I also dabble in open source software, and actually last year in this conference I talked about a software called GraphTerm. That's actually what I'm using right now. So the question I'm trying to address is, students said they like to use laptops instead of lab computers. Even though we had 20 computers, about 5 students didn't want to use them, and they used their own laptops because they can take stuff home with them. So can we set up a group of laptop computers to work together as a lab? Can we retain some of the advantages of a physical lab? And can we go beyond the limitations of a physical lab, because a virtual lab opens up lots of possibilities? So that's the question I'm addressing today. So some of the desirable features in a virtual computer lab, you want user authentication because you have many students. You want some isolation, so each has their own set of files. You want remote access from home, for example. But you also want, in addition to isolation, you want sharing of files, etc., as needed. And it'd be nice to have live sharing, so you can have live collaboration that you can do in a physical lab where in a group project, students gather together around the terminal and work on a project. So what are the current options? You can run a public IPython server, but it's only a single user with the same file system at the moment, although I believe that's going to change soon. There's some other options like Jiffy Lab. It was discussed earlier today. It uses a Linux container for each user. There's Bakari, there's commercial, but with free basic accounts. It's cloud-based IDE. And there's also Sage Math Cloud, which is probably the most sophisticated of the lot. It has a virtual machine accounts, and has terminals and notebooks and stuff like that. So these are the current options. So what I decided to do, since I already had software that could do some of these things, I decided to see if I can extend it to support a virtual computer lab. So students access this server on a remote computer, and they can automatically create Unix account using a group code. And they can either use a number to access the computer or use Google authentication. I don't like passwords on computers I maintain for others because there's security issues. And for student computers, only sensitive information would be a password. So I don't have passwords in this setup. And students had a choice either to run the IPython notebook server in their own account and access it using an HTTP port. Or they could use a lightweight notebook interface that's built into GraphTerm, which has additional collaborative features. And it's also compatible with IPython notebook. It writes the same format notebooks, and you can read the same format notebooks. And there are two ways to set up a virtual lab. If you have a dedicated physical server, you just install the program GraphTerm from SciPy, and then you run a command like the one I did just before I started my presentation. But I set it for one user, but you just set it up for multi-user mode. It'll just respect the existing users and allow them to log in with an access code or Google authentication. If you don't have your own dedicated server, you can use the Amazon Web Services. Again, you launch GraphTerm, and within GraphTerm, there's a command called easy to launch, which I'll show you later what the screen looks like. It launches a server on Amazon. It takes about 10 minutes. You can configure it with different kinds of software like PyLab or R, and it'll be up and running as long as you want. So this is what the login screen looks like. There's a username and a code or Google authentication, and there are no passwords. So this actually is an embedded terminal. I've embedded a terminal in the talk itself. And I'm going to, if you type the URL that you see on top here, lab.gterm.net right now, this is what you'll see. And I'm going to, this is basically an iframe. That's where you can see the web page. So I'm going to create a new user. Let's say Gamma. And I'm going to use the group code that you see here. So a new user is created. So I give students the group code, and using the group code, they create their own accounts, and then they can open a terminal that if they want to use that. And in this terminal, they can either run, do the usual command line things, or run the notebook server as well. So if you want to try it out, you can go to lab.gterm.net and type in the group code and choose a username that's unique to you, like your initial and your last name or something like that. But I'm going to continue while some of you may try that. So what are some of the things you can do with this server? You can, the instructor can view students' terminal sessions at any time. It's like a physical lab where you can go peer at what people are doing. And the way things are done is you have the username and a session name for each terminal. So you just type that in as a URL, and you can see the terminal. And normally students can't see each other's terminals, but for group projects, I activate groups, and students in the same group can see each other's terminals. And there's a simple chat where all the people looking at the same terminal, they can type stuff that appears as an overlay on the terminal, so they can discuss things that appear on the terminal. So the chat session is unique for each terminal. And as I said, there are two options for a notebook interface. And here there's two embedded terminals here. And those were set up, the lines you see, they were set up when I did the setup command earlier. So I'm going to take control of this terminal, and I'm going to run standard Python command line. And I can actually blow up this terminal because I want to see it bigger. So it's the same terminal. I just clicked on it to blow it up. I can how to take control of it. So you can do inline plotting. So this is like the Qt console of IPython, but it's not a notebook yet. But if I press Shift-Enter in this console, it becomes a notebook. And I can say plot 2, 3. Now we're actually in a notebook. And I do Control-Enter now to plot. I can change commands. So using a typical notebook, and if you want to go back to the command line, I just type Control-C. I'm back to the command line. And the commands you type in the notebook are still in the command line. You can go back and see those commands. So I can go back to the command line and type a new command. So I'm back to the command line version of Python. So all of this is happening with the standard Python interpreter, which is just seeing input fed from GraphTerm. So I'm going to quit the Python interpreter. Back in the command line, I'm going to launch the standard IPython server. So now the IPython server is running for this user. So I'm going to go back to my presentation. So this is the same terminal as before that IPython server is running. I'm going to open up this new terminal. So I'm going to open up a standard IPython notebook in the IPython notebook server. So this is one of those Aero Python notebooks I downloaded. So I just click on it, and now the IPython server runs in the terminal. And this is possible only with the new version because it takes file name paths. You couldn't do it with the cryptic numbered version earlier. But what's happening now is a full screen version of GraphTerm that's running an IPython notebook server. If you want to get out, I click on this X. And I'm back in the command line. So you can do the usual IPython notebook things. When it's basically an iframe that's embedded in this page, so that's why you can do that. So let me go back to my presentation. Moving on. So this is an actual screenshot from when I was using this in the lab, and you can see various students with the username and the terminal name and how they were idle, for how long they were idle. And sometimes you see things like exercise 6, number 2. So that's the notebook they're running. And it says they're working on the second cell of the notebook. So I can keep track of how much progress they've made in an assignment, so I know who to find out about or who to ask about what they're doing. And you can also click on the names of the terminals and open up and look up multiple terminals at the same time. So here I'm looking at 3 students' terminals who are in 3 different stages of their assignments using the notebook. So it's like a physical computer lab, and you can look at what students are doing real time. And you can actually take control, hopefully with their permission, and type commands in as well. So the final big thing I want to talk about today is what I call progressively fillable notebooks. So one problem I've had is, if you show an IPython notebook to a student, you have to show the question and the answer at some other time. You have to keep like 2 versions of a notebook and decide when to show them the answers. Do you show all the answers at the same time? Or you show, if there are multiple parts, you show one answer at a time? Or you make slow students, you make the quick students wait for the slow students so you can show them the answers. So there's all kinds of uncertainties about hiding the answers in an IPython notebook because it's a pretty open format. So what I have is a variation of the notebook where you can have multiple coding tasks, It's called a progressively fillable notebook. And when you start, you only see the first task and the markup associated with it. When you complete it, you'll see the answer, which will be executed, and you can move on to the next cell. And this also guarantees that if you have a complex task that depends on earlier tasks being completed correctly, that's guaranteed because each earlier task will be completed. And the other thing is, the last attempt by the student is saved in the notebook itself, and you see it in the example next. So it's better to actually see the example than to try and explain it. It's a little complicated. So this is the question that a student might see, and there are two parts, but he only sees the first part. And it says fill in code here. So the student has to write a function here and write a function here, and the function is tested with this piece of code, and this is the expected output. So this is what the student sees. So the student can type in the code here and do Control-Enter to execute it any number of times. And when they get the right answer, or they want to go ahead, they type Shift-Enter, and then they'll see this. They'll see the right answer that was missing in the earlier part, which will be executed so they can go on to the next step. And they also see the wrong answers they typed in and the wrong output, which is basically saved as markup before the code cell. And then they see the next question, and they can proceed like that. So you see the expected output, which can also be a graph that they have to reproduce. So they know the target, and it's like a fill in the blanks, but you do one question at a time. And then you can submit the result as your answer to your assignment. How much time do I have? 7. So let me do a demo of this fillable notebook. So if I go to the list of notebooks, so this is the one I'm going to look at. It says progressive fill. So this is the task that I have to write a function that returns the sum of the absolute values of two numbers, another that's the difference of absolute values. And it says fill in the code here. So I'm going to try typing two functions. Obviously this is wrong, but let's proceed anyway. So this is my attempt at an answer, and I'm going to press Control-Enter. So this is the output I have, and this is expected output. So obviously I'm not getting the answer. So I can try this a few times, and let's say I give up. Then I press Shift-Enter. It confirms that I want to proceed. And what I see now is part 1, the right answer right away. So I can see what the right answer is. I can also see my wrong answer out here, and the wrong output. And the right answer is pasted and executed. So if the next task involves using function defined in the previous task, it'll work. So this is the next task. Again, I could type in something, press Control-Enter, and I'm going to give up. I press Shift-Enter. And so it's basically a plot, and you can compare your plot to the expected plot. And the wrong plot is also saved in the output. And the way you create a fillable notebook is very easy. You just add these comments that you see here. You just add that to any line, so it'll be hidden. And you add the suffix -fill to the name of the notebook, and that's all you need to do to create a fillable notebook. You take a regular notebook, make sure you execute the pieces of code and produce the output. And what will happen is all the expected output gets converted to Markdown, and it's basically not output anymore. But the student gets to see it in the fillable notebook. And I mentioned I'll show you how you create an Amazon Cloud instance. When you type EC to launch, you see a web form which looks like this. Again, this is within the terminal, and it actually, the command line arguments map to a form. So you can select whether you want PyLab, whether you want R or NetCDF, and various options, and you hit submit. and it'll actually create this command line for you. The nice thing is, if you want to change something, you don't have to go back to the web form again. You just go back and edit the command line. And then it'll create the server in about 10 minutes. And the reason this exists is because this is what I use to test GraphTerm itself, too. You can just launch Cloud Instant. It costs about 7 cents an hour or something like that. And you can do that. I'm going to skip this. Some of the shortcomings. If you don't have a dedicated server, you need Cloud Instant. It costs about $50 a month. It might be worth it, depends on the situation. You need good internet connectivity in your classroom to do this. The GraphTerm client runs on a browser, so it's not operating system dependent, but the server requires a terminal, so it'll only run on a Mac or Linux. And the notebook interface, which the students really like, I like it too, but one thing I find is they download a file and they have no idea where it is because they're not used to the command line anymore. And so they lose some of the complexities of programming because the notebook interface makes it so simple. When you let them loose in the real world, I wonder how they'll do in a complex project, but maybe most of them will never need to. But let's hope that. So conclusions, virtual computer lab can duplicate some of the advantages. You can have sharing and chat, and the command line and GUI interface can be used to do complex tasks. And a virtual lab can do things a physical lab cannot do. I mean, you don't need to be there, and you can have experimental things like fillable notebooks where you can get instant feedback. So the quick student will get the feedback before the slow student, so the whole class doesn't have to wait to see the right answer. It'd be nice to see a variant of this implemented in the standard IPython notebook in some form, so we could use it in that as well. Thank you. Questions?
The fillable notebook is a neat idea. Is there a way to prevent a lazy student from just zipping through it?
Yes, I'm a teacher, so I know there are all kinds of safeguards built in. So unless students actually talk to each other, as long as the student doesn't talk to another student, you can ensure that they can't create 2 copies of the notebook and copy the answer from the previous version. Yeah, you can ensure that. So they'll only see the current task, and they'll only see the next one after they complete the task, and they can't do the current task again. But if they talk to another student, all bets are off.
What was that short URL again at the beginning?
Oh, sorry, you can just go here, and if you want to find the URL for the lab, it's lab. For my slides? Okay. Let me quit this. Any other questions? Yep.
Do you think this kind of software could benefit in physical labs too?
We still have a physical lab, so I will use it there as well. Because, as I said, the virtual lab can do things a physical lab cannot do. So I'll be using it there. So it'll be hybrid for a few years. And, yep.
I have a question. When the students want the right solution, pressing Control
Shift Enter, yeah.
that code was given by you?
It's a standard notebook. I just hid the code. I put those comments that hid the code, and then it just comes back. So you start with a working notebook, you put special comments on certain lines, and rename it, and then you create a fillable notebook.
Yeah, that's fantastic work, Bill. It's very interesting, and it works. Congratulations. But I was thinking if this is more aimed at undergraduates or how I was just thinking how I experienced when I have joined an online course out of curiosity, and I have encountered these courses that force you through a path, and you have to finish something before continuing to the other. And as an adult learning, I have been very annoyed by that. Like, very
No, but
I kind of like this kind of pattern. So I wonder if you know and more advanced students, perhaps, this constrains them, whether this is more to guide them?
No, actually the reason for this is not to punish students. It's because I would give students a task. It's complex. There's step A and step B and step C. And step B had defined functions. Step B uses those functions. And they get stuck in step A and never get to step B or C. See here what they'll do is they get stuck in step A, they hit shift enter, then they can do step B and step C without worrying about step A. So in some ways it's to free them and do more complex things. But if they get one part right, one part wrong, especially in tests, they get stuck with a syntax error somewhere and they can never get to the end of the program. So it's like so I can give partial credit. Often I find it difficult to give partial credit because either the program works or it doesn't. And here you could divide it up into 4 tasks, and they could miss the first task, but if the second and third.
But you give them an option to decide if they want to sidetrack I think I heard that you can give up at one point.
Right.
Give me the answer, I just want to move on.
Right. There are 2 ways. One is you give them the fillable notebook, then they can do it on their own pace. But there's a mode where you can do it synchronously when it's different. You can control it. That's a choice you make. You can just give it to them, and they can just skip on to the next step.
So you have, is there a bit of code that you have to download to start building this fillable?
You have to use the GraphTerm server, because the standard IPython notebook server doesn't support that. But you could start with a standard IPython notebook and convert it.
I'm just a little confused about the relationship between your notebook and IPython notebook. And did you fork IPython? Or
No, it's like the Qt console more than a notebook. It works with any command. There's even a bash version of the notebook. You could see that. It just looks for prompts in the command line and feeds the command line the pieces from the cell. So it's completely independent. But I made sure it can read and write the IPython notebook format, and it has very similar command structure. Because I use both. I switch between one and the other, but they're basically independent. Thank you.
All right. Thanks once again. And give another round of applause, yes. Right now, so feel free